Now, yesterday, I told you I was saving secant cubed for today. And I think I gave you a little bit of a warning of this one is especially different. So you've got notes out. This is the only trig function that you have to go through integration by parts to solve. And in just a little bit, we're going to do a review of what are all of these functions, integrals, and what are the various ways to integrate with different exponents within each type of trig function. So I want to ask you a very important question. If you were to take only part of this and integrate, what part would you take that you know you can integrate? And what did you say? Right. I just wrote this backward. So u is what I'm going to differentiate. dv is what I'm going to integrate. And we know how to integrate secant squared because it is an answer to a derivative. So secant squared is the answer to the derivative of? Tangent. And then what does that leave for u? If I've taken secant squared and the dx, I'm missing one secant x. And I'm going to take the derivative of that. And what is the derivative of secant? Secant x times tangent x. And what is the formula for integration by parts? U times v minus the integral of v du, the two results. When I put those together, I have secant x and tangent squared x times dx. Now, this is actually the first time I'm talking about how to deal with secant with an odd exponent. So the fact that I've got secant to the 1 power in that integral says, let's not focus there. With tangent, what did I say yesterday about when the exponent is even? What do you do to tangent? And mind you, if secant had been even, you would rather go the direction of what to do with secant when it's even. But because I don't have that with my secant, and I've got an even tangent, what did we do? Anyone remember? Use trig identity. Which trig identity? Right, the trig identity. Or the, sorry, I just repeated myself on that. I meant Pythagorean. The Pythagorean identity. Tangent squared is equal to secant squared minus 1. I need to distribute the multiplication of my secant over that subtraction. And let me insert some space. Actually, a lot of space. Keep going, more space, more space, more space. Okay. So now I have secant x times tangent x minus the integral of. Distributing, I end up with secant times secant squared and secant times 1. Now, does anything in there look familiar, like very recent, very incredibly recent familiar? Yep, and I got one person in person and one person online saw it. Secant cubed is very, very, very familiar. That's what I'm solving. I'm solving for the integral of secant cubed. Now, if you're solving for an integral and you find that integrand show up inside another integral, that's actually good news. That's actually good news. I can split this subtraction into two integrals. So I'm going to put down that all of this is equal to the integral of secant cubed dx. I have secant x times tangent x. And then I'm going to split this into two integrals. That means I have minus secant cubed x dx, and then minus negative, so plus, the integral of secant x. Anyone see how beautiful this is yet? This is an equation. Mind you, on the left side, I have the integral of secant cubed x dx. I heard it somewhere. Yep. Anyone online see what to do? Or is that just too much to type? So we are going to add to both sides the integral of secant cubed x dx. And when I add that over to the left side, I have two integrals. So 2 times the integral of secant cubed x dx is equal to secant x times tangent x plus the integral of secant x. Now, I do need to integrate secant x. I'm going to hold off for a second on that and say that I need to divide both sides of the equation by 2. And now, secant x is one of the functions that you should have had memorized, but I have not gone over it anytime recently. Part of it is with the AP test. I am pretty sure that this does not show up on the AP test. So I think the last time I talked about this was with my classes when use substitution was brought up. So doubt that you remember it. Now, yesterday, I'm going to have to come back to this. Yesterday, we talked about how to find the integral of tangent. Do you remember what we did? Mm-hmm. So everyone work on this integral right now. If you ever forget the formula for the integral of tangent, you can actually come up with it really quickly if you remember that the trick, my computer's getting finicky again. Okay, we're back up. All you have to remember is to turn it into sine and cosine and just look carefully at what you have. If you make the denominator be your u in a u substitution, the derivative of cosine is negative sine x. Am I going to break before summertime hits and get something new? I'm definitely getting something different for next year because I'm hearing that the only thing they're giving us for technology is, well, you've got Chromebooks. I need to figure out what tablet I want to get that will connect well enough to all the school stuff. If any of you have any suggestions, let me know. Anyway, I'm also hoping to find sales sometime before fall. Anyway, so if this is my u, my du is, I'm actually replacing sine x dx with negative du. And then at that point, I'm just dealing with negative the integral of 1 over u du, which is negative natural log of absolute u, and of course plus c. So you need to know that formula. Also, you may want to be ready to recognize it as the same thing as the natural log of secant. Using a log rule of multiplication by -1 turns into an exponent inside the logarithm, and a -1 exponent says reciprocate. So we've got our integral for tangent. Secant, not so kind. You can go through a process like we just went through a process with tangent and see it all unfold. The problem is, what you have to memorize to remember an initial step toward finding the answer means you might as well memorize the whole thing. So I'm going to show you. I'm going to erase some of this to get it out of the way. So what you have to do is, you've got this lovely integral sitting there going, hi, I'm secant. I don't have anything else here. And then all of a sudden, bring in a whole bunch of stuff. As long as I multiply and divide by exactly the same thing, I'm not changing the function. I will comment that I open up the possibility of a domain difference. That would be the only thing. Other than that, multiplying the top and bottom by exactly the same thing doesn't change the function. And it's not something you would necessarily guess. Here we go. Would you have thought of that? Now, I don't know how long it took someone to come up with this or what they processed to get to the point of realizing what it was. But here we go. I'm going to now treat this in the same manner that I did previously for tangent and make u the denominator. What's the derivative? So let's start with secant. What's the derivative of secant? Secant x times tangent x. And then what's the derivative of tangent? Look at your numerator. I need to distribute over that parentheses. Do you see it? Secant x times tangent x would be when secant x times tangent x would be when I distribute my secant over to this tangent. Secant squared x would be when I distribute my secant x over to this secant. So all of this times dx is replaced with du, and this is u. So this integral turns into the integral of 1 over u du, and we go to natural log of the absolute value of u, and u is secant x plus tangent x. So that is telling us that the integral of secant x times tangent x is equal to the natural log of the absolute value of secant x plus tangent x. Plus c, of course. But do you see what I mean by if you can figure out how to create the process to find the answer, you might as well memorize the answer. Because you have to remember to bring in a multiplication and division of secant x plus tangent x. And if you've got that much, you might as well throw a logarithm on it and call it a day. So know that you need to memorize this formula. You need to be ready before we move on to trig substitution. You need to know how to deal with every single trig function that shows up in an integral, as long as it shows up in the format of that trig function to a power. And now we can come back over here and finish this up. The integral of secant cubed is equal to 1/2 secant times tangent plus 1/2 times, and do you remember it now that it's not in front of you? What is the integral of secant? So now you know that if secant shows up on its own, you need to have that formula memorized. If secant shows up with an odd power of 3 or higher, before you start crying, or no, remember to go to integration by parts and then start crying. Maybe you can imagine how awful this could get if this were a higher odd exponent. You're not going to be asked to go there. So I will be very cautious about when secant cubed comes out. I'm never going to throw it on a test for you. I want you to remember, though, that you need to turn it into integration by parts. And just remember the beginning of that, because that's useful to just have in your repertoire. Now, tomorrow, we are going to continue to review trig integrals. And I'm going to be waiting until probably Friday. I'll start the trig substitution. Know this. We need to practice trig integrals for a while before I quiz you on it. I know there are a lot of AP tests next week that many of you are going to be gone for and studying a lot for. So what I'm thinking is we're going to keep practicing these trig integrals while we learn trig substitution. And then we're going to keep practicing and keep practicing. And then in a couple of weeks, once we're past this next flood of AP exams, I will quiz you one at a time through these techniques. So there will be a day where I give you a quiz for just trig integrals. And the day before we do that, I'm going to just fully power through a review of that. And you will have been doing these problems a lot in the meantime. So I'm going to start with, you have 6 trig functions. You need to know the integrals of all 6 trig functions. So we're going to start off with, what is the integral of sine? This is, yes, I dislike tremendously dealing with these 2 integrals. What is the integral of cosine? Positive sine. What is the integral of tangent? There are 2 options. The textbook version that you might see is the natural log of secant. But if you have to go about finding this, you're going to come up with negative natural log of cosine. What is the integral of secant? Natural log of secant x plus tangent x plus c. Now, we have cotangent and cosecant left. We're going to go about finding them in a way similar to the way we found their non-co-conspirators. When we looked at finding the integral of tangent, we changed it into its sine-cosine nature. What is cotangent in terms of sine and cosine? And then what do I want to make my u? I'm always wanting for these problems, for these 4, I'm always wanting u to be my denominator. And they will always be set up in a way where the derivative of the denominator is the numerator with the dx and everything. So I'm going to write down that my u is sine x. My du is a positive cosine x dx. So this turns into the integral of 1 over u du, which is then the natural log of the absolute value of u, sine x. And realize that if you forget this formula, you can come up with it. I'm about to erase this so that I can just write down the answer. Yes?
Do you think it would be useful to think about it as negative natural log of cosecant that follows like that negative and then the other rule?
You know, whatever works best for you to remember, use that. Okay, I'm going to erase this. And I will say that all four of these trig functions have other ways they could be written. The one that you're least going to write in other ways is secant. But you might kind of keep in mind, if you want to do things a certain way with memorizing, cotangent could be the natural log of the absolute value of sine, but it could also be negative the natural log of cosecant. And that just depends on how you're going to process better the memorization. And now for the last one. How did we go about changing the integral of secant in order to get to where we are here? How did we manage secant? I can't fully hear you. Uh-huh. Well, let me remind you that when we had secant, we multiplied and divided by that secant x plus tangent x. Is that what? Yeah, I can't hear. The maths make it so difficult. How frustrated have you? Oh my goodness, are any of you like working where you have customers you have to hear? Is it frustrating? An adventure. Okay, so any guesses on what you might multiply the top and the bottom by? And there are actually multiple correct answers. The easiest thing, if you're just trying to memorize, is like you did with secant, but with cos, bring in cosecant plus cotangent. This isn't going to get you the textbook answer, but it's going to get you an answer. So if u is the denominator, cosecant plus cotangent, what is the derivative?
Negative cosecant squared plus, or I did negative on the outside, cosecant squared plus
Your words are stumbling. Okay. Yep. Jackie's beat you to it with typing.
Probably easier to type than to say.
Yeah. So derivative of just cosecant is negative. And by the way, let me kind of take you through it because I know people need this. When I look at what's the derivative of cosecant, I first ask, what's the derivative of secant? Everybody, what's the derivative of secant? Secant times tangent. So what's the derivative of cosecant? Negative cosecant times cotangent. And then when I see tangent, when I see cotangent, I first take myself to tangent. What's the derivative of tangent? Secant squared. So what's the derivative of cotangent? Negative cosecant squared. And can you see that that is the numerator times -1? When I distribute cosecant through that numerator, I am going to get cosecant squared plus cosecant times cotangent. And that's just pull a negative out. So this turns into negative du over u. So I'm integrating negative 1 over u du. That's going to give me negative natural log of the absolute value. And then that's cosecant plus cotangent. Now the textbook version, instead of using addition of cosecant and cotangent, they do a subtraction. And through that subtraction, they wind up not getting the multiplication by negative 1. But if you just need to have a correct answer, you need to remember things in whatever way you're going to remember them easier. And in a way, I find it actually helpful to do things in the way of, let me show you. If the answer to my integral is a co, it's also negative. Watch this. If I go with certain versions, if the answer to my integral involves a co, it's negative. If the answer to my integral involves a co, it's negative. And notice that non-cos, no negative. Non-cos, no negative. Non-co, no negative. Non-co, no negative. If I use the textbook version of cosecant, that changes. If I use this version, I get the pattern again of where I have cos with my answer for integral, I've got negative. And I'm just going to throw out there the textbook version is positive natural log of the subtraction. That subtraction causes an issue with the negatives negating. And you can play with it and see that that does happen, but you're going to find your way of remembering all 6 of these trig functions integrals. Whoops, I started erasing that one. In whatever version you remember it. Now, what if you have an exponent? We have pairing issues. Sine and cosine very nicely pair together. Tangent and secant pair together. Cotangent and cosecant pair together. If you have any mixture of pairings, I repeat, if you have any pairing mixture, for example, look at that one. That's not one of the pairings. Just convert everything to sine and cosine. Every one of your trig functions can be changed into sine and cosine. So a quick reminder of the reciprocal identities. What is secant in terms of sine and cosine? 1 over cosine. What is cosecant in terms of sine and cosine? What is tangent in terms of sine and cosine? What is cotangent in terms of sine and cosine? Make sure you know how to change any of these 4 back to sine and cosine, and then deal with it from there. And in fact, you can do that every single time you run into stuff, but it might create a situation that goes way too far out there just to snap back, if that makes sense what I'm saying at all. But anyway, so we have some basic rule ideas to follow. For the sine and cosine pair, you want to remember that the question is all about whether you have an odd or an even exponent. And this is whether they're alone or together. If you have an odd exponent, you're going to do a U substitution where U is its partner. And from there, you're going to use the Pythagorean identity. And I want you to realize that this covers the situation of if sine shows up to an odd exponent by itself, if cosine shows up with an odd exponent by itself, if sine and cosine are multiplied together, and one or the other or both of them have an odd exponent. Only the situation of they both have odd exponents do you have a choice. But just remember to make U its partner. So if sine has the odd exponent, U is cosine. If cosine has the odd exponent, U is sine. And then when I say Pythagorean identity and sine and cosine are involved, you remember that it's, say it out loud. What's the Pythagorean identity with sines and cosines? Right, sine squared plus cosine squared equals 1. Oh, Jackie's got it, all typed out. Now, if P is even, and you don't have the option of an odd P, actually, let me express that you don't have the odd situation. So this could be, you see sine to an even power by itself. You see cosine to an even power by itself, or you are multiplying sine and cosine, and they both have even exponents. If one of them is odd, go the easier route. Pythagorean identity is the easier route. If this is the case, you're not doing a U substitution, at least not straight up. The first thing you're doing is what? First thing you are doing is bringing in a particular trig identity. Do you remember what that pair of trig identities is?
The sine squared equals 1/2, 1 minus cosine, 2x.
Mm-hmm. So they both start with 1/2 times, and then you've got a 1, a plus or minus, and then a cosine 2x each time. Who gets the minus? Who gets the plus? Now, I want to show you how this pair of formulas is additionally powerful enough to give you some more trig identities. What I want you to do is take both of these equations and isolate cosine 2x. And you will come up with another pair of trig identities. I'm going to multiply by 2. And then if I'm going to isolate my cosine 2x, what does that make cosine 2x be equal to? Did you get 1 minus 2 sine squared x? Now let's take the other one, multiply both sides by 2. And isolate cosine 2x this time. And what do you wind up getting? For cosine 2x, there are actually 3 trig identity possibilities for it. These are the main two. In my opinion, I think of them as the main two. If you needed the third one, take either of these two, and it's actually a mixture with Pythagorean theorem. You end up getting it in terms of a mixture of these two. I don't want to bring it up because I don't find it to be that useful with the calculus sequence to know that. But just kind of take a good look, realize that this gives you another pair of trig identities. And I want to point something out to you. I gave you this study guide. It's on Google Classroom. I put it under Notes, Summary of Advanced Trig Integration. And first, I've got the integration by parts. We will be going over that again and making sure you have it down. Then there's solving trig integrals. Soon we're going to do trig substitution. And then we are going to continue with fraction decomposition. We have only learned this first one so far. Formulas you should have memorized. For integration formulas, I realized I'm actually missing one of these, and I also am not giving you all the options here. So you need to know your power rule, 1 over x, exponentials, and then know your 6 trig functions. Be familiar with also the fact that secant squared is the answer to taking the derivative of tangent. Cosecant squared is the answer to taking the derivative of negative cotangent. Secant times tangent is the answer to taking the derivative of secant, and then I realized that I was missing that the integral of cosecant cotangent would be what?
Negative cosecant.
Mm-hmm. So the integral of cosecant cotangent would be negative cosecant. You need to be ready for integrating any batch of trig functions. And these are only trig functions. We aren't multiplying by any polynomials. We aren't bringing in any exponentials with the trig stuff. You need to make sure, other than the trig stuff, these are the only formulas you need to remember. So there's a lot with trig in integration. As far as what identities do you need to remember? We've got our Pythagorean trig identities, but realize that if you know this first Pythagorean identity, you can get the other two through it. You can either divide both sides of this equation by sine squared, and you'll get this one, or you can divide both sides of this equation by cosine squared and get this one. For the other trig identities that you want to be ready with, these are the two that I was just talking about. And I also showed you how you can use them to come up with the trig identity for cosine 2 theta if needed. And this one hasn't shown up yet, but it will be showing up, sine 2 theta. And I've got to tell you, and I do not know why, but people remember this. It just comes back into people's heads really quickly for some reason. People tend to remember sine squared plus cosine squared equals 1. But this is the second most remembered trig identity. Sine 2 theta is 2 times sine theta cosine theta. And those are the only identities we're going to be concerned with. Now, if in the future you ever need to use any other trig identity, you can look it up. And you're not going to just be thrown an integral without any explanation of what trig identity to go to. So just keep that in mind and realize that you've basically got everything you need for trig. Now, that was just the sine cosine pair. Now we have the tangent secant pair. With tangent specifically, we're hoping to find P be odd. If P is odd, we're going to do a U substitution where U is its partner. And in this situation, who is tangent's partner? Secant. Then we are going to use the Pythagorean identity. And in this case, which Pythagorean identity are we looking at? Mm-hmm. Tangent squared plus 1 equals secant squared. Still working with tangent. If P is even, do you remember what the go-to is if P is even on a tangent? You're going to first bring in a trig identity. Do you remember which trig identity you need to use for this situation? You need to replace tangent squared with the Pythagorean theorem, or Pythagorean identity, secant squared minus 1. So it's Pythagorean identity again. But I just kind of want to point out to you some similarity of pattern. With sine and cosine, you're hoping for odd. If you see an odd exponent, make u its partner and use Pythagorean identity. Same with tangent. If p is even, then you're going to start off by throwing in some trig identity. Now, for sine and cosine, that took us to this pair of trig identities. For tangent, we use this identity. Then we have secant. I'm going to start with if p is even, because secant is the one we're hoping to find even. If p is even, we're going to make u be equal to its partner. And what is secant's partner? Who is secant's partner? Tangent. And then we're going to use the Pythagorean theorem. Pythagorean identity. And do you see how similar this is with these three trig functions for p being odd? It's the same idea. Secant is the one thing you don't want to show up even. Odd. If p is odd, I'm just going to say you're going to have to turn to integration by parts and have fun. It is the only one that you have to go to some other method. And that's as far as I'm going to say. And know that I'm not going to put an odd exponent on secant with no way out. And by no way out, I mean you don't have an odd tangent exponent right there. I will not give that to you on a test. That means it could show up in homework. But homework is one thing, a test is another thing. Now, if you understand the tangent-secant partnership, the cotangent-cosecant partnership is exactly the same thing. In fact, I am going to do a lasso. Oh, no, wait, I don't want a lasso. I just realized. I want to do copy-paste because I want to keep it. I'm going to have to change some of this, but not too much. Okay, I accidentally grabbed a little bit of other stuff, but I just want to make sure you're aware that it is essentially the same thing. I'm going to take some stuff out of here that's just really aggravating. That's how I take out aggravating. And only one thing needs to be changed here. This isn't the trig identity. That's the trig identity. Other than that, all of this is the same thing. So if cotangent has an odd exponent, who is cotangent's partner? Cosecant. If your exponent on cosecant is even, who is its partner? Cotangent. And then from there, the trig identity that you're focused on is this one instead. So you've got homework tonight. If you need to, you can use the solution manual to help you out. But according to my in-class folks, my time is up.